Okay, so let's get started with our first sample problem that we have over here. Um, this problem right here says how much heat, Q, is required to warm a 138 gram piece of aluminum, whose specific heat capacity, that's what that C is equal to 0.89 joules per gram degrees Celsius. We're going to heat it from 18 degrees Celsius to 37 degrees Celsius. And we're going to calculate how much heat is required. So we're looking for Q. We're going to use this equation. The equation is Q, oops, I don't have my pen going here. There we go. Q is equal to M times C times delta T. You might go, well, where did you get that equation from? We got this equation from, you remember in the lecture on the what do you call it, PowerPoint, there was a definition for specific heat capacity. Specific heat capacity C is equal to Q over M times delta T. And remember that Q is heat. M is mass. Oh, let me go ahead and undo that. M is mass. There you go. And delta T is change in temperature. There we go. And really, delta T is just equal to the final temperature minus the initial temperature. So how much heat is required? We're going to go ahead and just solve for Q here. So let me go ahead and do this. I'm just going to change the pen color. Go, okay. We need to find out what Q is, so let's solve for Q. And to both sides of this equation, we multiply M, and it cancels on the right, ends up on the left. We multiply delta T, cancels on the right, ends up on the left, and then we just flip them around. So we end up with our equation here, Q is equal to M times C times delta T. A lot of people learn this equation this way. Our book had us learn it in this way, right? But we can use the other one. So what we need here is to go ahead and put Q here. Our mass is going to be 138 grams. Just plug in the mass, 138 grams. Your specific heat capacity, you were told up here, was 0.89 joules per gram degrees Celsius. So we're going to multiply by 0.89 joules per gram degrees Celsius. I'll put it like this, per gram degrees Celsius. And so as you can see, the grams are going to cancel out here and here. And then what we need is the delta T. What is the change in temperature? And the change in temperature here is going to be, well, the temperature is going from 18 degrees Celsius to 37. So it's T final minus T initial. Here's your T final. Here's your T initial. So delta T is going to be equal to 37 degrees Celsius minus 18 degrees Celsius. 37 minus 18 is 19 degrees Celsius, almost 20 degrees Celsius. 19 degrees Celsius. So that's the number we're going to put in here, 19 degrees Celsius. So we have our M. Let me go ahead and put this in blue here. Put it in green just to change. There's our mass, M. We got the M from here in the problem. Our C was given in the problem. And our delta T here, we calculated it over here, and that came from calculating the initial temperature and the final temperature. So we can just go ahead then and finish off the problem. Let me go ahead and get the black color again. And go, okay, 138 times 0.89. Now I'm going to go ahead and get my calculator out and calculate this out. 138 times 0.89 times 19 is going to give me 2,334. It's actually 2,333.58, but I'll use 2,334. And you'll notice that the units for this are in energy units because the grams cancel out. Those are your mass units. The degrees Celsius here cancels out with the degrees Celsius and the delta T, leaving us just with joules. And so we're going to leave that joules, and joules are our units of energy. And there is your answer, 2,334 joules. Okay. If you wanted to turn it into kilojoules, you can just divide by 1,000. Remember, you can take that and you can go ahead and make the conversion. Remember, the prefix kilo means 1,000. So kilojoule is equal to 1,000 joules. And in order for joules to cancel out, I have to put the 1,000 joules on the bottom and the 1 kilojoule on top. So basically, I'm just going to go ahead and take the 2,334 and divide by 1,000. And that's going to give me 2.334 do that, kilojoules. Okay, that's another way of expressing it. I didn't ask you for this. This was fine. I'm just showing you that if you're ever asked for kilojoules, to turn joules to kilojoules, you divide by 1,000. To turn kilojoules to joules, you multiply by 1,000. Just like we would do with kilometers and meters and kilograms and grams, kiloseconds and seconds, anything with kilo in it. That's how you convert from the kilo unit to the non-kilo unit. Okay. One last thing, and that's pretty much this problem here, but I'm going to go ahead and do one last thing here. Let me go ahead and move this up. Let's say you were asked to turn this answer into calories. And I tell you that, get my pen back here. There you go. 1 calorie equals to 4.1, oops, get rid of that, 4.184 joules. So 1 calorie is 4.184 joules. Because you have this equality, you can go ahead and convert the joules to calories also. So 2,334 joules we can go ahead and convert. So again, we want joules to cancel. So the side of the equation, the equality here, with joules in it goes in the bottom, 4.184 joules. And the other side of the equality goes on top. That's 1 calorie. And I have to remember that's lowercase calorie because remember in the lecture we said that there was some issue with the uppercase calories. So what this is telling us is we have to take the 2,334 divided by 4.184. And when you do that, you get 558. 558. 558 calories. So this is the same amount of energy as this many joules right here. Okay. So if I were to ask you the question above, all you would have to do is give me the answer circled here. Go ahead and change the color here. You would just have to give me this answer right here. That's fine. But if you were asked to give me the answer in kilojoules, you would then convert it to this answer over here. And if you were asked to give me the answer in calories, then you would give us this answer right here. Okay, so I just thought I'd kill a few birds with one stone. We answered the question. We could go back just real quick to recap what the question was. The question was, how much heat, Q, is required to warm a 138 gram piece of aluminum from 18 degrees Celsius to 37 degrees Celsius? And we were able to go ahead and use this equation here. Just plugged in mc delta T right here, here, and here, and we got our Q. Okay. All right, so that's the first sample problem. There's videos for another couple more.